Hello guys, welcome back to my YouTube channel. Please, I urge you guys to like and subscribe and also comment, and please click on the notification button so you can get notified anytime I upload a new video. So now this is an entirely new topic. Let's say I have rounded up my first order differential equation. Now we're going to be looking at second order differential equation. So how are we going to solve the second order differential equation? Now, second order differential equation can be solved by so many methods. So basically, we are going to consider second order homogeneous differential equation. Now, this is the general form for second order inhomogeneous or non-homogeneous differential equation actually, and this is the general form for second order homogeneous differential equation. This is it right here. So a homogeneous differential equation will be equal to 0, while a non-homogeneous differential equation will be equal to a particular function of the independent variable. So now, the solution of the solution of a second order homogeneous differential equation can come in 5 ways. Now, for example, if we are to solve this particular equation and we have solving it, we will arrive at a quadratic equation, and those quadratic equations, they are real and different roots. Automatically the solution becomes c1 exponential m1, one of the roots, times x plus c2, which is the second constant, exponential m2, which is the second root, times x. Now if the two solutions are real and equal roots, meaning that m1 is equal to m2, and but they are both real roots, the solution automatically becomes c1 plus c2 times exponential one of the roots times x. Now if you are given a complex root while solving, the solution becomes exponential the real root times x, open bracket, c1, one of the constant, cos the imaginary number times x, plus the second constant times the imaginary number times x. Given the form, the second derivative of y with respect to x minus n square y equals 0. Now if you look at this particular function, the first order here is missing. So given this particular form of equation, the solution automatically becomes y equals c1 exponential nx plus c2 exponential minus x, or c1 cos nx plus c2 sine nx. Now given this other form of equation, d square y divided by the x square plus n square y is equal to 0. The solution automatically becomes c1 cos nx plus c2 sine nx. So now let's take a particular example. Taking the first form, taking a particular example to see the first solution, to see how we can arrive at the first solution, then we go to other solutions. Taking an example on second order homogeneous differential equation. So how to solve this is a very simple step. We call it the operator D method. So we're going to make use of the operator D method in solving this differential equation. Now, what does an operator D method mean or states? Now, an operator D method means that D is taken as d over dx, and d square is taken as d square over the x square. Very simple. So basically, what do I need to do is to factor out my dependent variable, which is y, right? So I have d square over dx plus 5 d over dx plus 6, open bracket, y. Is that taken? Equals 0. So basically, then I replace my factors here. Here I have d square plus 5d plus 6, open bracket, y equals 0. So basically, you can, in some cases, I can actually give you the question in this form or the question in this form. Either ways, they are both the same. So now, to solve this particular differential equation, we factorize this quadratic equation here. So to factorize this quadratic equation here, or to solve this quadratic equation here, we have 6d square is equal to the two factors that I can multiply to give me 6d square, and either add or subtract to give me 5d square are both 3d and 2d. So basically we have plus d and plus 3d and plus 2d are the two factors that can actually work for this equation. So basically I have d square plus 3d plus 2d plus 6 equals 0, right? So d open bracket d plus 3 plus 2 open bracket d plus 3 equals 0. So my d is equal to minus 3 or minus 2. So like I said, if you have a real and different root, like I explained earlier before the starting of the video, like I said, if you have a real and different root, the solution to a homogeneous differential equation automatically becomes y is equal to c1 exponential m1x plus c2 exponential m2x, where m1 and m2 are the roots of the equation. Now basically this minus 3 and minus 2, minus my m1 is what? Minus 3, and my m2 is equals to what? Minus 2, right? Are roots of the equation. So basically I have two roots here, minus 3 and minus 2. m1 is equals to minus 3 and m2 is equals to what? Minus 2. So basically the equation of my homogeneous differential equation here is equal to y is equal to c1 exponential minus 3x plus c2 exponential minus 2x. That is that. This is very simple and easy method of solving differential equations. So let's take another example in case we have real and equal roots. In this particular question, dx squared y is equal to dx squared plus 4 dy dx plus 4y equals 0. So now, like I said, in case you are not given it, for example, I said you can be given this part in the second order homogeneous differential equation in form of the operator D method, in form of this form here, or you can be given in form of this. So basically you can choose to express this to this, that's that, or in case you are given directly as this, you can just factorize straight away to get your solution. So basically we call this general solution. Now to get the general solution of this, we use operator D method. Basically, without skipping all these steps, we know that my d square y is my d square divided by dx square is my d square, right? So we have giant D plus 4D plus 4 open bracket y is equal to 0. Is that taken? So that's that. I actually explained how we can arrive at this form on my first example. So you can see my first example to see how I arrive at this form. So factorizing this particular equation, we have d squared plus 4d plus 4 is equal to 0, right? So factorizing this is 4d squared is equal to, what are the two factors I can multiply to give me 4 and add to give me 4d, which are 2d and 2d, right? Plus 2d plus 2d. So solving this, we have d squared plus 2d plus 2d plus 4 equals what? 0. Then d open bracket d plus 2 plus 2d plus 2 is equal to 0. Then d plus 2, d plus 2 equals 0. Then my two roots are minus 2 or minus 2. Take m1 to be minus 2 and also m2 to be minus 2. So, like I said, the solution, in case you have a real and equal root, the solution to your second order differential equation automatically becomes c1 plus c2 open bracket exponential either one of the roots m1x. Is that taken? So we are going to apply this. So the solution to this differential equation becomes y is equal to my c1, which is an unknown constant, plus c2 open bracket exponential, picking one of the values of the root, minus 2x. Now this particular question, d square y over dx squared plus 4 dy dx plus 9y equals 0. So let's solve. So solving this, we said my d is equal to d over dx squared, then over dx, then my d square is equals to d square over dx square, right? Then putting this in this equation, we have d square y plus 4dy plus 9y is equal to 0. Then factoring out y, then I say d square plus 4d plus 9 open bracket y is equal to 0. So to solve this is the d form. I call it the d form. So basically you can be given exactly like this equation. Basically you can be given a question which is expressed like this or like this. So basically if you are given like this, the second step is to solve this inner equation here. Or if you are given like this, the first thing you do, express it in this form, then solve. So solving this inner equation here, we have now in this case, if you look at this, it cannot be factorized because if I multiply 9 times d square, we're having two factors that you can multiply, which are only 3 and 3. But 3 and 3 cannot give me 4d. So basically, let me use my quadratic formula method. So I have my minus b plus or minus b squared minus 4ac over 2a. We have my a here, which is in front of d, which is 1, right? And my b, which is plus 4. I have minus 4 plus or minus, which is 4 square minus 4 times 1 times my c, which is 9 over 2, right? My a is 1. So I have minus 4 plus or minus my 4 square, which is 16 times 9 times 4, which is what, 36, right? 16 minus 36, we have 16 minus 36, we have minus 20. We have minus 4 plus or minus 20 over 2, right? Then this gives me minus 4 plus or minus 1, the root of minus 1 times the root of 20. Now the root of minus 1 is what? A complex number, right? Which is minus 4 plus or minus j times, now 5 times 4 here will give me 20, right? Then root 4, which is what, 2, so I have 2 root 5, right? So this gives me 2 root 5 all over 2. So I have minus 2 plus or minus j 2 root 5 all over 2, right? This gives me minus 2 plus or minus j 5. Is that taken? Is that understood? So basically what we are seeing here, we are having a complex root. Is that taken? Where d is equals to this, right? Don't forget. So we're having a complex root. Now in this case, like I gave you earlier on, I said if you are given a complex root of, for example, let's take it to be m is equal to alpha plus or minus g beta, the solution to that differential equation becomes y is equal to exponential alpha x, that's the independent variable, open bracket, c1 cos beta x plus c2 sine beta x. So basically now if I compare this with this equation I have here, comparing this with this equation, is minus 2 plus or minus j root 5. Like I said, to solve this particular differential equation, given the form d square y over the x square plus n square y equals 0, the solution to this particular differential equation becomes y is equal to c1 cos nx plus c2 sine nx. As easy as that. So basically, just looking at this particular equation, what is my n square, comparing these two equations right here? What's my n square? My n square given is equal to 16, right? Which makes my n equals what? 4. So basically substituting it in this equation, I have my general solution becomes c1 cos 4x plus c2 sine 4x. As simple as that. So let's take another example. My last form or solution to possible differential equation. Now taking this particular question, now we see this is a slightly different form compared to this. Now there is also a standard solution if we are given this particular form of differential equation. Like I said earlier on during the start of the video, I said given a particular form, d square y over dx square minus n square y equals 0, the solution to this particular differential equation becomes y is equal to exponential, so y is equal to c1 exponential nx plus c2 exponential minus nx. Or you can just basically say y is equal to, when they simplify this using hyperbolic function, then we have c1 cos nx plus c2 sin nx. Is that taken? So basically either you can express it in this, the solution to be in this form, or you can express it to be in this form. So let's solve. Let's compare it to the equation we have. Now comparing this to this, what's my n square? My n square is equal to what? 3. Right? So since my n square is equal to 3, my n becomes what? Root 3. Right? So fixing it in the equation we have, my solution to this particular form of differential equation becomes c1 exponential root 3x plus c2 exponential minus root 3x. Or you can easily express it as c1 cos root 3 x plus c2 sin root 3 x. As simple as that. So like this is, we've come to the conclusion of solving all possible form of homogeneous differential equation. So basically when you are given a particular homogeneous differential equation, the step is to express it in the d form of solving the differential equation. Then either if it's a quadratic equation you factorize, or if it's maybe a cubic equation, then you solve using cubic form of solving an equation. So basically, to know the kind of solution you should have, you should basically know, is required for you to just cram the forms of solution you have to have given a particular form of differential equation. So now our second topic, we're going to be considering how to solve a non-homogeneous differential equation. Thank you guys for watching. Please and please subscribe.